Hi, AP Calculus AV, Unit 2, Review Corrective. So this is the back side. This is the graphing calculator side. And so we're going to try these problems, get ready for the retest. So I'll talk about some of the mistakes I saw. First one should hopefully be pretty easy. Make sure you're in degree mode for everything except for the sign regression problem for this test in the worksheet. So cotangent, I mean, maybe somewhere in your calculator there's a cotangent button, but to me, I like to just write it in terms of tangent and show that. That's your work. I mean, if you hope to get any partial credit, if you write that down, I'm going to give you credit right away. So, and then hopefully you 1 over tangent. Now we do 32. Now let's make sure I'm in radian mode, so I can switch to degree mode. On this one, I don't think it'd make as much matter as much because we'll actually put the degree symbol in there. So second angle degree, 10 second angle minutes, 8. Now seconds is all the way down here in the plus degree, alpha plus. And so there's our answer. 1.589886. So for answer, final answer, 3 decimal accuracy, rounded or truncated. I'm a big fan of truncated because it's easier and harder to mess up. But on this one, you could also do 1.590. So one of those answers. Okay, next one. We're going backwards and trying to solve a trig problem. So secant. So to me, again, I don't know where my secant or inverse secant buttons are, so I'm going to rewrite this as 1 over cosine equals -3. I'm then going to flip both sides. So this is work you should show. And then I'm going to find alpha, the reference angle. Now the reference angle, inverse cosine of positive 1/3. Ignore the negative because you want to get a first quadrant answer, which is where everything is positive. Now your calculator, I think that's just the safer way. If you do inverse cosine of -1/3, by the way, this is what it gives you, which I don't know. Sometimes you got to understand principal value. So I'm not going to do that. I'm going to base it off more the way I do these problems by hand, which is always find the reference angle first. Write these down more than 3 decimals for my work. Okay, and then now I go back here to negative and I say, okay, well that would be quadrant 2 and quadrant 3, right? Quadrant 2 and quadrant 3, and I don't want quadrant 2, so that means I'm going to go with quadrant 3. So quadrant 3, it'd be 180 plus alpha, right? So I just need to add 180 to this, and I get theta equals 250.528. Now, on the test, I made you guys do degrees, minutes, seconds. So some of you guys just forgot. Some of you guys did it wrong. So degrees, minutes, seconds. I also want 3 decimal. Actually, it's easy on here. Second angle DMS says, oh, you want to change your previous answer to degrees, minutes, seconds? Here it is. So in degrees, minutes, seconds, it's 250 degrees, 31 minutes, 43.606 seconds. 3 decimal accuracy is still expected. So there you go. All right. Solving triangles. You got to watch out on these ones. I would draw a picture just to kind of set things up. So just, you should, usually like to put the known angle right here. Not that you have to, but the other ones don't really matter. 7, 6, label the sides. Now I would say, well, what situation do we have here? We have angle side, ASS. So this is the one where we might get 2 answers. Okay, And usually what I tell you guys is to predict whether you're going to get two answers. Oh, wait, hold on a second. This is a little B. This is a little A. I messed up. Okay, you should label that. It's not ASS. It's side angle side. So not possible. Two answers, just one. Okay, now when we do this, if you're to set up law of sines, which might be a good first thing, you can say, okay, well, sine of A over 7 equals sine of B over 6 equals sine of C, which is 25 over little c. And we can't solve this. We need at least two of these that only have one unknown, but they all have an unknown, so we can't do law of sines yet. So we got to start with law of cosines, and it's going to be involving the angle and the side across from it. So it's going to be c squared equals a squared plus b squared minus 2ac. Some of you guys forget the minus, some of you forget the 2. Cosine of 25, or a big C. So I'm going to fill these in. So c squared equals 7 squared plus 6 squared minus 2 times 7 times 6. That should be a B. Cosine of 25. So c squared equals 49 plus 36 minus 84. Cosine 25. C squared equals 85 minus 84 cosine 25. Now, some people are like, oh, 85 minus 84, that's 1. You just violated order of operations. You have to do multiplication before addition and subtraction. So, no, you cannot do that. Square root of both sides, plus or minus. We're going to use the positive one. So, square root of 85 minus 84 cosine 25. You got to make sure you're in degree mode right now because it's a degree angle. That's our answer. 2.978279015. You need to write more than 3 decimals because you're going to need this for further steps in work. Some of you rounded to 3 decimals here and it threw off your answer and it took off points. Okay, so we have C. So we can plug that in up here. And then we can find angle A or B. Now, you're like, well, I got to find angle A. Let's just find angle A now. Remember the whole small, medium, large idea? You have to find the smallest angle first, and then the medium, and then the large. If you don't, what happens is if the largest angle, which in this case would be A, right? A is the largest angle. It's across on the large side. If it's obtuse, your calculator's not going to give you that. Is principal value. So we avoid that and we force our calculator to find the smaller angles first, and we always find the last angle, the sum of the angles of a triangle. So we need to go with angle B first, even though we want angle A, because the small, medium, large. A lot of you guys messed that up and you got the wrong answer on the test. So we're going to find angle B. So we're going to say, okay, well, sine B equals 6 sine 25 over 2.978279015. And then so angle B equals inverse sine of that, 6 sine 25, 2.978279015. And we get, so inverse sine of 6 times sine 25. Now here's a trick. Divided by the previous answer, so I don't have to type all that. And it keeps it super accurate. And that's our answer. So let's see, that's 58.3643724.9. So then angle A, the way we're going to find angle A is the sum of the angles of the triangle 180 minus angle C minus angle B. So 180 minus 25 minus 58.3643724.9. All right, so 180 minus 25 minus the previous answer. Oops. Minus the previous answer, because I don't want to retype all that. Take advantage of those little tricks. So angle A equals 96.63562,751. And for the final answer, we're going to say 96.635 degrees. Or if you really are into extra work and potential mistakes, you could round, and if you did it correctly, you'd round up. Some people rounded, tried around and messed it up. They had the right answer, and if they just truncated, they probably would have gotten it right. Now the area of triangle ABC, well, area is just 1/2 base times height. That's what you should be using, 1/2 base times height. Isn't that what you've always used? Now the base is whatever side you know. I wouldn't use C as the base because it's ugly. I don't know, I'd use 7. Draw the height in and figure out what the height is. You got to use some basic trig. You can't use 7. It doesn't split this side into 3.5 and 3.5. You have to use trig right here to find this. So the height, so we're going to do opposite over hypotenuse. You use sine of 25 equals opposite over hypotenuse. So h equals 6 sine 25. So the area of the triangle is going to be 1/2. I'm going to use 7 for the base, 6 sine 25 for the height. So, I mean, this is the exact answer, by the way, right? I mean, we could even write 21 sine 25. That's the area. But we can plug in our calculator too, 21 sine 25. And we get 8.874983. So the area is 8.874 or 8.875 if you're into that. Okay, so you got to watch out for that. You got to do small, medium, large. And watch out for the ASS problems though too. Okay. Number 4, find the coordinates of a point in quadrant 2, 30 units from the origin, if cotangent theta equals 2. Okay, so this is 30. Probably going to draw like a triangle here. I'm trying to find the x coordinate and the y coordinate. Now, I think I need to find this angle, or I need to find alpha from this. So cotangent is the same as 1 over tangent, right? And then I could flip both sides. And then I can find alpha by doing inverse tangent of 1/2. Inverse tangent of positive 0.5, 26.56505118. So we can find the angle. I don't think we have to find the angle. We don't. I wouldn't find the angle. I would just say, okay, well, that's alpha, and let's use basic trig in here. So if I want to find x that's adjacent, that's going to be cosine of 26.56505118 equals, cosine of that equals adjacent over hypotenuse. And the thing you got to watch out for is that this should be a negative x coordinate, right? This is going to be positive. So we'll make it positive afterwards. So x equals 30 cosine 26.56505118. So 30 cosine the previous answer. It's a quick way, don't have to retype it. 26.832815. Okay, so, but we got to make it negative. Okay, so this is your x, but then you got to make it negative. And then y is going to turn out positive, so that's fine. So that's going to be sine, opposite over adjacent, sine of 26.56505118 equals opposite over hypotenuse. So y equals 30 sine 26.56505118. On my calculator, 30 sine. Now the one thing about this is I actually would have to type it in now. 26.56505.118 is 13.416407787 is your y value, and that should be positive because you can just see it's in the second quadrant. So your final answer as an ordered pair, 3 decimal accuracy, negative 26.832, comma, 13.416. If you wanted to round, that would change the x value negative 26.833. But so there you go. Okay, Trion Hill, everyone's favorite. It's all about the picture first. And some of you guys' pictures were way off. Some of them were close, but just too messy. And you'll have a lot more room on the test. But it's all about the picture. So I'll probably use most of my space here to do the picture. So we have a slope, a hill. I just draw it going up. Vertical tree. I mean, before I even read the details of the problem, if I know it's this tree and hill with the shadow and stuff, I'm gonna just draw my hill. I'm gonna draw my tree. Okay, now it says shadow uphill. This is where some people made a mistake. It said up, they went down. It said down, they went up. Okay, and then you connect these to get the sun. And then I'm gonna draw horizontal lines everywhere because they're going to form all these special angles. So let's go. Tree of a height 35. So the height of the tree is 35. I'm going to try and write small so I can read it and stuff. 30-foot shadow. Okay. If the angle of elevation is 40 degrees, this is 40, then what is the slope of the hill in degrees? X. So there we go. Now these are all tied to this transversal. So if that's 40, this is 40, alternate interior, this is 40, this is 40, okay? And these are all tied to this one right here. So if that's X, this is X, this is X, this is X, this is X, okay? Now there's a lot of right angles formed here. The tree with a horizontal is always gonna be a right angle. So this is gonna be 90 minus 40 is 50. And this is a right angle, so this is going to be 90 minus x inside the triangle, and then that's going to be x plus 40. So I'm going to redraw this triangle without all the extra stuff, just because 50, 35, 30, 90 minus x, x plus 40. What is the slope of the hill in degrees? Now on the test, you had to find this side right here for one of the problems, right? Which I think you would use law of. And we could start with law signs. Sine of 50 over 30 equals sine of x plus 40 over 35 equals sine of 90 minus x over, we don't know, distance. So if you had to find that distance, I think you'd have to go with law of cosines, right? Because, well, it depends. You'd have to find x first, and then you could use this to find that distance. But you could find the distance right away from law of cosines. So if we call this, say, like a d, you'd, yeah, you would want to use this angle, the known angle, and you'd say, okay, well, 30 squared equals d squared plus 35 squared minus 2d35 cosine of 50 degrees. But that would be nasty to solve. So probably not going to do that. You could do it in the future with graph calculator. We'll talk about how to solve equations easily. Anyways, back to this. We're trying to find x. What I called x. I just focus on these. This one has too many unknowns. That we wouldn't call that x also. So I'm going to solve for x. Now, a lot of you guys just called the whole angle x or something like that, which is it's dangerous because it's actually x was 40, all right? So sine of x plus 40 equals 35 sine 50 over 30. And then so then x plus 40 equals inverse sine of 35 sine 50 over 30. And that's going to equal 30, let's see, 35 sine 50 divided by 30. Oh, wait. Okay. Inverse sine of that, we get 63.344298. And then we're going to subtract 40 to get the actual angle. Because what we just found was the whole angle right there was 63, which a lot of you guys did. And then you just left that as your answer. But what we're looking for is only part of it. So we're going to subtract 40, 23.344 degrees. 3 decimal actually rounded or truncated. Okay, so probably going to see another Trion hill. How about concentric circles? Usually in concentric circles, there's two circles. You're given information about one, and you use it to find information that leads you to the other one. So if you're not using both circles, then something's very wrong. Circumference of the inner circle is 100 miles. The whole thing, circumference. The radius of the outer circle is 5 miles longer, okay, than the inner circle. The arc length to ADC, the long way, is 80 miles, which I think is the only thing that would make sense in this picture, if the inside is 100. So that's 80. So I'm just trying to label this, find angle ABC. So I'm probably trying to find this angle right here. I might find this angle first, though. We'll call that beta, because I think that would be easier with the way the information is. I don't want to try and find the length of this arc that's not even there. So we're going to use the information from the inner circle to get the radius of the inner circle to then find the radius of the big circle. So we have a little r, and then we have a big R. And big R is just little r plus 5. So we got to find little r first, though. So circumference is 2 pi r equals 100. And so we solve for little r, and we get 50 over pi equals little r. So that means big R equals little r plus 5. I had to write all this stuff down. 50 over pi plus 5. That's your big R. So then we're going to use this idea that the arc length per ratio of the arc length over the whole circumference equals the angle of the whole circle. So theta over 360 degrees equals the arc length over the circumference. This basic idea from geometry. So in this case, the arc length is 80 miles. The circumference is 2 pi big R for the big circle. And so then theta equals that times 360. Now, I mean, we could leave this all crazy ugly, or you could distribute this and make it a little nicer. It'd be 100 plus 10 pi times 360. And so now this is going to find the big angle. So let's see. 80 times 360 divided by parentheses 100 plus 10 pi. You better put parentheses around that denominator. And we get 219.1515196. If you get a negative angle, something's wrong. If you get an angle bigger than 360, something is way off. Now, let's see. Okay, so our angle is going to be 360 degrees minus theta, right? So 360 minus 219.1515196. So it's going to be 360 minus the previous answer. So it's 1 140.8484804. So our answer is going to be 140.848 degrees. Round truncated comes out the same. So if you dared round, I hope you rounded correctly. So that's pretty typical of all the concentric circle problems I've given you. You have information about usually maybe the inner circle. You use it to find the radius of the inner circle, which is somehow related to the radius of the outer circle. And then you use this idea that the angle over 360 equals the arc length of the whole circumference. And you solve it. Carefully, show your work. Okay, sign regression. Now, one of the big mistakes people made is that if there was PM, they just type those in. And then you get this graph that has like 100 periods, or not 100, but like 10 or 15 or something, which should probably strike you as weird. So you got to add 12 to these, 14, 20, 22. And so we got to enter these in, stat, edit. I have a bunch of numbers in here already, so I'm going to delete these real quick. I'm going to type these in: 1, 4, 10, 2, 8, 10. If you enter the PM times, it doesn't know it's PM. So what happens is it just treats them like they're the same time. So you got to make sure you do that. 42, 47, 54, 71, 63, 58. Now I'm going quick, but I'm going to double check. Really check this closely. Make sure we did these all correct. One little one off is going to mess it up. Now, if you have like a TI Inspire, or like a Casio, or maybe even TI-9, your sign regression comes up a tiny bit different. All your other problems should be the same. Now, I'm going to get out of here. I'm going to go to the home screen. I'm going to go stat, calc, near the bottom, sign reg. And if I just say list one, if I just hit enter, it's going to pick list one, list two. Otherwise, I have to type the list in with a comma in between them, second the numbers. We're going to write this all down, everything that we see right there. So I'm going to say, all right, sign reg. Essentially, you're going to copy the whole screen down. Y equals A times sine bx plus c plus d. A equals 13.2739334. B equals 0.236948888. C equals negative 2.2214704003. D equals 56.05614619. So that needs to be on there. Otherwise, I'm just taking off points. All right, so that's what you should get. Like I said, if you have like TI Inspire, these numbers are going to be a tiny bit off, and you're going to get answers that are really close to mine. Okay, so I'm gonna draw a sketch graph of this. This is like over the time of a day. So I should go to Window. Oh, we got to go to Y equals and get this in here. So we go to vars, statistics, equation, EQ, reg equation, enter, and paste it in there for you. It's pretty cool. We're also going to graph the line 55. We go to Window 0 to 24. And I'm going to go -1 to say 90. Graph it. Oh, that's not the straight line because it graphs in order. There's the straight line. Oh my goodness. What happened? Oh, I'm in degree mode. Go back, just graph it again. You shouldn't have to redo anything. So there you go. That looks better. And there we go. So I'm going to sketch that. Just quick sketch graph. Okay, so we want to know when is temperature at most. At most means less than or equal to. Some of you guys didn't interpret that correctly. At most means less than or equal to. So solid dot, solid dot, and then everything underneath. So that's a picture of our answer. We just got to figure out what times these happen at. So that's going to involve intersections. Second calc, number 5, intersect, first curve, second curve. Guess. Sometimes I use the little cursor to do it if it's close. Let's write that down. 9.039169. And another one, second calc. Number 5, intersect, first curve, second curve. Now, I don't want to, this is 24, right? So I'm going to say, looks like around 22. That's my guess. It's quicker than 22.96999. So these are interval answers, and we're including the beginning and end of the day. So it's going to be 0 to 9.039 bracket union. Now, if it just said less than 55, we'd still have bracket at 0, but an open dot here in parentheses at 9.309. 22.969, comma 24. And these are hours in a day. I don't need to change it back to AM PM. But you got to put the units. Now, if you did round this, it would have been 22.970. Okay. The time and the temperature is increasing most rapidly. So that's when it's the steepest, which is probably somewhere around there. But what we're going to do is we're going to graph the derivative graph. Now, wherever the slope is 0, we're going to get x-intercepts. But we're going to trick it. So we're going to go to y equals. We're going to I'm going to probably just turn this guy off. Go down here. If you have it stored, then cool. Otherwise, math 8 in derive vars, y vars function y1, comma x, comma. Usually this is where we put a value of x that we want the derivative at, but we're going to trick it and do all the values of x in the screen. If you try to do this on the home screen, that would give you an error. Okay. Now, if I go to graph it right now, it's going to graph the first graph, which might be nice the first time just to line things up and see. Our answer should be right here. There should be a peak down here. Now, it's really hard to see because it's a lot smaller, and it's also down here, so we're missing part of the graph. But if you were to line this up, this is kind of what it looks like. If I kind of exaggerate it. Now, I really want to see that graph, so I'm going to go back to y equals, turn this off, do zoom fit, which takes a few extra seconds of work because it's got to pre-calculate all these values, plus just calculating all these derivative values is a lot of work for the calculator because, I mean, it's doing tons of derivatives. So it takes a bit of time. Just use that as a chance to breathe. So here's a nice zoomed in version of your graph. That peak right there is when it's increasing the most. A valley, probably over here, would be when it's decreasing the most, would be right there. Okay, so we want to find this right here. That's what we're looking for. So we're going to do second calculate maximum, and you got to get to the left or right of it. So I mean, you could say, oh, well, this is 12. So I'm going to say 6 to 12, guess 10. Or you can use the cursor to go back and forth to get your left-right balance and guess. It's taking a little bit of time again. There it is. So this is 9.375256, comma 3.1452446, which is not the way you should write your answer. This is an absolute maximum answer. So I'm going to say the temperature is increasing most rapidly. I'm going to put the rate, which is the y value here, right here, 3.145 degrees per hour. I want units at time times t, or time, t equals 9.375 hours. I need units. So So what is the max min that you were looking for, and where did it happen? This is the safest way to answer this, because I guarantee if you don't do this all the time, you're going to lose points on the AP test unnecessarily. Average rate of change. Now, if I said average temperature, so average temperature would use this thing called the mean value theorem that we've talked about. And we'd say, well, let's find the area under the curve. And then imagine we level it out as a rectangle and divide by the base of the rectangle and get the height. So we're going to do 1 to 10 of the original function and then divide by the base. But this is rate of change. So this means derivative. So average rate of change is average derivative. But guess what? That means you're going to integrate the derivative, find the area under the derivative. It's a little different. Now on your calculator, that just means you're going to have to do it on the graph that we just talked about, this graph. So I'm going to do second calc, number 7, 1 to 10. So it's going to find the area under this curve. Now, you got to read the question carefully on the test, retest, whatever. You can't just go on autopilot. You can't just say, oh, well, this is what I've done. Okay, so we're going to put that. So it's going to be 14.111627 over 9. And I think I can just say divided by 9. It takes me a home screen and does the correct thing. So it's going to be 1.567958. So the answer is 1.567 degrees per hour is the average rate. If they asked for average temperature, we would do that, and it would just be degrees. So there you go. Anything that was on the original test is still fair game, even if it wasn't on this corrective, but this is a lot of good practice. So